In the previous video, I talked about mutation with setter methods. So now there's a question of how exactly can we test whether these changes actually occur. So, we can see that they change, yes, with this one example, but let's say we want to write unit tests for this. And in general, I will say that you don't normally have to write unit tests for accessors and mutators, but it's important to know how to test methods that have side effects, like mutator methods. Okay, so let's say we want to test the test mutator methods. So what we're gonna do, we're gonna create a point with the coordinates 3, 4, and then we're going to have an assert all, or an assert equals, it doesn't matter. So, well, I guess it kind of does matter. So we're going to show you how to do this with assert all, because it's important to know what exactly you need to do when you're testing a void method. Because remember, the whole point of that void, no pun intended, with this void method, or these void methods, is that they have a side effect. They change the state of the point object that you're calling it on. Okay? So what you want to do to test this is we'll first change the state of P1, and then we'll check to see whether that actually did anything. Okay? And so what this means is that to test your mutator methods, you need to make sure that your accessor methods also work. So to be very rigorous with this, we could say assert equals 3 and then p1.getX. Okay? And then let's now say that we want to test that changing p1's x coordinate is we want to test that a change to the x and the y coordinate, as we'll show later, actually occurs. So we first need to change the x coordinate. So the way to do that, at least with this lambda expression, is we can just call the method like so. Okay? So remember that an assert all receives a bunch of stuff to do, and it will do this in order. Okay? So it will just run all of these expressions one after another. Okay? There's a little bit more nuance to it than that, but that's generally what this is doing. Okay? And there's not much more nuance to it than that. So it's actually, I think it's very straightforward to understand. But what it's going to do is it'll run this assertion statement, it'll run this lambda expression, and then it will, so this will actually cause a change in the state of P1. Okay? So now that we actually change the state of P1, we want to show that that change is actually persisted in the P1 variable. So the way we might do that is just by having another assert equals method. So we'll call assert equals, but we'll say that we expect it to be what it was changed to. In this case, 42. So if we just try this out right here, we'll see that this should pass because, again, these are fairly straightforward methods, so they should work. But again, we're being as rigorous as we can with this, just to get a better understanding of how to test methods that have side effects inherently. Okay, so again, just to be very rigorous, we'll do the y coordinate as well. So we'll say the expected value for the y coordinate is 4. We'll change this to, let's say, -10. It doesn't really matter. So we expect -10, and then we will see that this should work just fine. Let's see. Oh, no, it doesn't because I wrote the test wrong. Now it should work, and it does. Okay? So, in addition to doing these changes, or rather, in addition to testing that these changes occur with the setter methods, which isn't all that interesting, we can test things like dot equals, dot toString, hash code we could test, different things we could try. So we'll try the toString method as well. So let's first test to see that the toString method works as we expect by doing assert equals x equals 3, y equals 4 on the string. And then we set it to be, we set the x coordinate to be 42. So of course this should change to x equals 42, y equals 4. And then we don't need to test this again because there's no point. Again, no pun intended. Now we just set the y coordinate to be -10, and now the y coordinate will get updated. Okay? So this should, of course, persist, that everything works. And I guess now, just for the sake of it, we can test to see that, so in addition to just changing how these methods work, they can also change how things are equal. So, for example, if we say that P1 is equal to the point, new point 3, 4, these should obviously be equal because they're the same point. But if we then change one of the x or the y coordinates, then they should no longer be equal. Okay? Because we change the state of the x coordinate in P1, so of course it's no longer going to be equal to the point 3, 4, because the x coordinate is changed. Okay? So yeah. So I mean, and this change should then persist to down here, and we'll just try it again just because we're being extremely thorough with this. So these should now pass, or they should pass. It's not that they should not pass, or that they never didn't pass. But one more thing we'll show is that when we write instance variables in the tester class, and we try to use something like before each, then whenever we call something like, or whenever we write the setup method, the changes in between each tester method will not persist. So basically, if you have something that affects the state of a point, then those will get wiped out, so to speak, whenever you use a before each. So for example, here we test to see that changing P1 will actually cause the changes to persist, but obviously if we didn't have this before each here, then changing the state of it would be affected across all of the methods, and then the initial assertions would be, or would fail. So we absolutely need this before each now to make sure that everything is, or the changes do not persist between methods. Okay? So let's rerun this, and as we see, all tests pass. And importantly, if we comment out this before each, then we will see that all of the assertions fail because, well, in fact, it fails for a different reason, because these points are null inside of all of these methods, but even if they were not null, the assertions would still fail because the state would be changed in between each method invocation.